Hello, everyone. Welcome back to the channel.
Have you ever wondered how websites like Netflix, Airbnb, and Dropbox handle millions of users without crashing? Or why some websites feel lightning fast, even under massive traffic? The answer often involves a technology called NGINX. And in this video, you'll learn what NGINX is, why it became one of the most important tools on the internet, how its architecture works, and why developers love it. Let's get started.
First things first, NGINX is pronounced NGINX. It's an open source software that can act as a web server, reverse proxy, cache, and load balancer. It was created by Igor Sysoev in 2004 to solve a huge performance challenge that was affecting web servers at the time. Today, it powers a massive portion of the internet and is known for being incredibly fast while using very little memory. But what made it so special? To understand that, we need to go back to a famous problem called the C10K challenge. Imagine your website suddenly gets 10,000 users connected at the same time. For older web servers, that was a nightmare. Most traditional servers used a one-thread-per-user model. So if 10,000 users connected, the server might need thousands of threads running simultaneously. That consumed huge amounts of memory and CPU resources. This challenge became known as the C10K problem, handling 10,000 concurrent connections efficiently. NGINX was built specifically to solve this problem, using a completely different architecture. And that's where its real magic begins. Today, NGINX is used for three major purposes. Web server. It can directly serve static files like HTML, CSS, JavaScript, and images incredibly fast. 2. Reverse proxy. Instead of users talking directly to your backend servers, they talk to NGINX first. NGINX then forwards requests to the appropriate backend service. This improves security, scalability, and performance. 3. Load balancer. If your application runs on multiple servers, NGINX can distribute traffic among them so that no single server gets overwhelmed. Think of it as a smart traffic controller for your application.
Now let's look under the hood. One of the biggest reasons NGINX performs so well is its master worker architecture. This architecture separates management tasks from traffic handling tasks, and that keeps everything highly efficient.
Here's how it works. You have one master process. The master's job is simple. Read configuration files, start worker processes, monitor workers, reload configurations when needed. The master never handles user requests directly. Then you have worker processes. These workers handle actual client connections and requests. And here's the crazy part. Each worker is single-threaded, yet it can handle thousands of connections simultaneously. How is that possible? The answer is event-driven architecture. Traditional servers create a new thread for every connection. When a request waits for a database response, that thread just sits there, doing nothing. Memory gets wasted. CPU resources get wasted, and scalability becomes difficult. NGINX takes a completely different approach. Instead of creating thousands of threads, a worker process listens for events. If one request is waiting, the worker immediately moves on to another request. No waiting, no blocked threads, just continuous processing. That's why NGINX can handle massive traffic loads with surprisingly low resource usage.
Let's talk about configuration. When developers first open an NGINX config file, it can look intimidating, but it's actually very structured. There are three concepts you need to know. Contexts. These are blocks like HTTP, server, and location that organize settings logically. Directives. These are instructions that tell NGINX exactly what to do. For example, listen 80. This tells NGINX to listen on port 80. Inheritance. Settings defined in higher-level contexts automatically flow down to lower levels unless overridden. This makes configurations clean and easy to manage. When your application grows, you'll probably run multiple backend servers. NGINX provides several ways to distribute traffic. Round robin. Requests are sent sequentially. Server A, then server B, then server C, and repeat. Perfect when all servers have similar capacity.
least connections. Traffic goes to the server with the fewest active connections. This works well when requests take different amounts of time to process. IP hash. The same user IP always gets routed to the same server. Useful for applications that require session persistence. Each strategy solves a different scaling problem. NGINX isn't just a popular tool. It's a critical part of modern infrastructure. It's trusted by millions of developers and organizations worldwide. It's also widely used in containerized environments and Kubernetes-based architectures where efficient traffic management is essential. If you're working with microservices, chances are you'll encounter NGINX very quickly. To see how powerful NGINX is, look at some of the companies that use it. Netflix uses it for large-scale video delivery. Airbnb leverages it for scalability. Dropbox uses it for high-performance file delivery. WordPress deployments frequently use NGINX for faster page loads. When companies serving millions of users trust a technology, that's usually a good sign. So here's the big takeaway. NGINX became famous because it solved a problem that traditional servers struggled with. Its event-driven architecture allows it to handle massive numbers of connections while consuming very little memory. It can act as a web server, reverse proxy, load balancer, and much more. And that's exactly why it has become one of the most important pieces of infrastructure on the modern internet. If you enjoyed this video, don't forget to like, share, and subscribe. Thanks for watching, and I'll see you in the next one.